All right, in part B of chapter 10, we're going to do confidence intervals for the difference of two means. So now we're talking about confidence intervals. So what's the formula for a two-sample t-interval for the difference of two sample means? What are the conditions for this to be valid? Is it on the formula sheet? So here we go. Here's the formula. Difference of the two means, plus or minus t star, and then here's your standard error formula we discussed. I know you can't see the minus here, but there should be a minus right there. Now, they are the same conditions as the two-sample hypothesis test, and the degrees of freedom is still really complex, so you're going to use your calculator or use the smaller of the two samples for t star when you're calculating that t star value. All right? Is it okay to use your calculator? Please do. And it's going to be stat test 0, and it's the two-sample t interval. Okay? And if it says ask for pooling, say no to pooling. So when doing two-sample t procedures, should we pool the data to estimate a common standard deviation? Is there any benefit? Are there any risks? Well, you can pool the data if the two standard deviations are exactly equal, but that's really rare. Okay, so the benefit of doing that is there's slightly more power because of a larger degree of freedom. But the risk is, if they're not equal, then the power can be very off. It can be very low and not the results that you want. Okay, so that's why we tend to say no to pooling on this, so don't worry about it. All right, Ashton and Olivia want to know if generic chocolate chip cookies have as many chocolate chips as name brand chocolate chip cookies on average. To investigate, they randomly selected 10 bags of Chips Ahoy and 10 bags of Great Value cookies and randomly selected one cookie from each bag. Then they carefully broke apart each cookie and counted the number of chocolate chips in each. And here's the results. There they are. So A says to construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. All right, so we're going to do our 4-step process. So first we need to state what we're doing. We want to estimate the difference between the mean of Chips Ahoy minus the mean of Great Value with 99% confidence, where mu C is the true mean of number of chocolate chips in Chips Ahoy cookies, and mu of G is the true mean number of chocolate chips in the Great Value cookies. So I've defined my parameter, put my level of confidence, and I said we're estimating. It's not finding, it's estimating when we're doing confidence intervals. All right, for the planned step, we're going to construct a two-sample t interval if the conditions are met. So I've named my test. All right, random samples were taken. It says 2 independent random samples were taken. They did it with each of the bags. They randomly selected bags and they randomly selected cookies, so that's good. Then, it's not an experiment, it's a sampling, so I have to do the 10% condition. So I took 10 bags of each. Is that less than 10% of all the Chips Ahoy cookies made? Bags of cookies? Yes. And is it 10 less than the Great Value? Yes, it works for both. So I've established that the sample is small enough. Now then for large, is my sampling distribution going to be approximately normal? Well, my samples are not greater than 30. So I have to sketch those samples out. So I created a dot plot. Looks like this. Remember, I'm looking for strong skewness and outliers. Don't have either. Okay, these are not strongly skewed at all. So I need to summarize what I found from this sketch. Don't just leave it as a sketch and put a check mark. That won't work. So what I would say is that there's no obvious skewness or outliers in either sample. So it's okay to use the t-distribution. That's what it tells me. Because it's inferring that if my samples look like this, then the populations are approximately normal. All right, so on the do step, you're going to see how great your calculator is in doing this for you, okay? First thing I have to do, though, is enter my Chips Ahoy data in list 1 and Great Value data in list 2, okay? So there it is. There's my data. So then I go to my stat test 0, which says two-sample t-test, and this is what shows up. And then I know I have data. I have the raw data right here that I entered in my list, so I'm going to use the data option. I confirm that my data is where it's supposed to be, and I put in the correct confidence level. And then, of course, no to pooling. I go to calculate. Boom, there it is. There's my confidence interval. There's my degrees of freedom. I do need to state that. Now, what are you showing for work? You're showing this information right here for your work. You really need to write all this down for proof that you've done it, okay? So, but bottom line, here's the confidence interval, and here's the degrees of freedom. All right, last step. Construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. So we found that, and we're going to interpret it. We are 99% confident that the true mean difference in the mean number of chocolate chip cookies in Chips Ahoy and Great Value is between negative 4.814 and positive 2.814. So that's saying I took number of Chips Ahoy and I subtracted the average number of Great Value chocolate chips. So notice that this ranges from a negative value to a positive value. That means zero is in there, right? Which means there may be zero difference between the two chips. Chip counts, basically. So B says, does your interval provide convincing evidence that there is a difference in the mean number of chocolate chips? Well, it would only be convincing if zero was not in the interval. It had to be all above zero or all below zero. But that's not the case in this one. So I would have to say no. Because the interval includes zero as a plausible value, this means that the true difference in mean could actually be zero. So that's a big no.